Okay, hello everyone. Good morning, good afternoon, good evening, depending on where you are in the world today. Thank you for joining today's CNCF webinar, Preventing Kubernetes Misconfiguration, Static Analysis, and Beyond. I'm Christy Tan, here from the CNCF, and I'll be moderating today's webinar. We would like to welcome our presenter today, Matt Johnson, Developer Advocate Lead at Bridge Crew. A few housekeeping items before we get started. During the webinar, you are not able to talk as an attendee. There is a Q&A box at the bottom of your screen. Please feel free to drop in your questions and we'll get to as many as we can at the end. This is an official webinar of the CNCF and as such is subject to the CNCF Code of Conduct. Please do not add anything to the chat or questions that would be in violation of that Code of Conduct. Basically, please be respectful of all your fellow participants and presenters. Please also note that the recording and slides will be posted later today to the CNCF webinars page at cncf.io/webinars. With that, I'll kick it over to Matt to kick off his presentation. Take it away.
Hey, thank you very much. Thanks for the introduction, Christy. Hi, everyone. Thank you very much for joining today. Whether you are, I'm based in Manchester in the UK, so whether you are ahead of me and it's quite late, or you are kind of California, America way and it's very, very early, I appreciate you getting up and attending. As said, my name is Matt Johnson, and we're going to today take a bit of a dive into Kubernetes configuration, infrastructure as code security, and kind of all that DevSecOps goodness. There we go. So just briefly, and these slides again will be available later on today on the CNCF website. We're going to look at kind of common security configuration issues that arise with kind of deployments and use of Kubernetes, looking a little bit at kind of the state of configuration issues we see from kind of public resources and kind of, you know, the common issues we see with customers or kind of publicly available Kubernetes samples. Look at how policy as code kind of tied into DevOps and CI/CD can go some way to making security, you know, more of an enabler than a chore for your development teams, and also look at what options we have for kind of post-deployment and runtime analysis of security issues within Kubernetes as well. So without further ado, if you want to ask me questions that you forget during this webinar, if you wake up tomorrow night and go, oh, I wish I'd asked that question, I'm at Metahertz on GitHub and Twitter. I'll put my email address at the end of the talk as well. Obviously, we have the Q&A box as well within this Zoom, so please do use that, and we'll save some time for questions at the end. A little bit about me. I'm an all-round kind of cloud security geek. I like breaking cloud connected IoT devices. The bigger the better. Cars and planes, if I could get my hands on them in my spare time. So I'm a bit of a wannabe pen tester on that side of things, which I think just means I like breaking things. And I'm also like super intrigued by the idea of kind of really lightweight Kubernetes clusters at edge sites for kind of consistent APIs across cloud and, you know, remote kind of survivable locations. So a little bit about me. If any of those interest you, by all means, give me a shout. So a little bit of a story to kick things off. I like a bit of context. As an engineer, I either want to move fast or I am expected to move fast with the advent of DevOps, GitOps, you know, multiple deployments to production a day. And when I am moving fast for whatever the reason, I do not want to break things. And so we will generally track what we're doing. We will track what changes we need to make. We will manage our sprints. We will manage our backlog in some way, which leads most engineers, you know, and whether it's this or whether it's another ticketing system, to have a love and hate relationship with Jira. And, you know, it's good to track what we need to do. It's good to think about security. I know that a lot of the time security historically has been a blocker to kind of fast-paced teams. So we will get widely, you know, affecting tickets like do not admit root containers. For a little bit of context, for those maybe newer to Kubernetes, in Kubernetes, kind of a container's user ID, whatever the user ID is within a container, maps to the host's user table. So a container running as root within the container, if there were any kind of file systems mapped into the container, if there were any kind of security issues which allowed container escape for that process, or a hacker could use those to become root on the underlying host if they break the container isolation. So generally speaking, we don't want to run root containers. But this ticket is, potentially a single engineer going through all the manifests, learning how to make sure you're absolutely telling Kubernetes not to do this through configuration, through YAML. This one ticket actually represents a lot of work if it's just in ticket form. Another one, do not allow containers sharing the host network namespace. Again, bit of context. Each pod in a Kubernetes cluster gets its own IP address of some form through CNI. If you allow the container to have the host network namespace, it can suddenly affect things for the whole host, multiple containers, potentially affect routes, kind of see other traffic, or just generally, not a good idea for most kind of deployments. So again, a very simple security baseline, something that we shouldn't be doing with most of our Kubernetes deployments. But again, that's a lot of work to go and find them, work out how to stop them, and make sure you're staying in compliance. And just because it's there in Jira doesn't necessarily mean that just magically becomes a solved issue. And a third example, let's not make sure SSH is open to the world on the cluster level or the security groups. So what we end up with traditionally from security, especially when you have kind of a security team, correctly enforcing these kind of best practices from CIS benchmarks, for example, onto a developer team, is you just end up with a lot of tickets. This is the first of two times we will defer away from the kind of Star Trek theming for our GIFs in this session. There will be another, but straight back to it. Picard tells us that resources are always limited, time, expertise, etc. So when we've been tasked to solve real problems, let's not waste our time. So let's look at the problems we actually need to solve. And to do that, we'll start with some data. I told you we'd be going back to the Star Trek theme. Anyway, so it's not just the Kubernetes manifests themselves. It's not just your pods having maybe root access, or maybe being allowed access to the network namespace, or the CES benchmarks and guidelines suggest you should have CPU limits set, so you're not going to swamp or allow a single pod to take down a node, or kind of annoy your scheduler or prevent other resources getting scheduled. It's not just the kind of things running on top of Kubernetes. You also know, if you've ever deployed a Kubernetes cluster, that Kubernetes doesn't just happen. You don't just have a Kubernetes cluster, or maybe you do because another team's deployed it, but they're still having to think about what are the underlying infrastructure that Kubernetes cluster is deployed on. Whether it's a cloud provider or bare metal or wherever, there are still going to be VMs, there is still going to be infrastructure, there's still going to be routing and security and firewall and IP addresses and storage attached, and a lot of things that, again, come with their own set of security best practices that need to be considered. So by the time you're getting to the point you're deploying Kubernetes manifest, you have your security of the pod or containers you're about to deploy to consider, and someone either in your team or in your organization has the security posture of the Kubernetes cluster and supporting services itself to consider. And so infrastructure as code is absolutely great. It gives us a way to checkpoint, to go back, to do drift detection, to see where we were and where we are, and kind of really do that historical audit if we need to, because we're tracking our infrastructure changes just like we track our code base changes. But it does create new learning requirements. It does introduce new risks, and therefore new opportunities to automate the CRUD out of these risks, and stop this being just a Jira bomb from hell. And as another example of what we're talking about within the pods, just because DevOps engineers aren't going to spend their full time being security engineers. Even kind of if you're implementing DevSecOps and you have security engineering working within your teams, there is so many best practices, there are so many standards, there are so many guidelines, there are so many things. If you kind of read a security basics in Kubernetes book. And that's just for Kubernetes. You've then got the same applies to Amazon or Azure or choose your favorite cloud provider, guidelines for securing their components, whether it be a cloud hosted EKS or whether just the VMs and the individual components needed to build your own. And there's no one way to solve a problem. You can see here we have a security context to make sure that the containers do not run as root. But then that can be overridden by a single container lower within that pod description. So, there's a lot of things that are quite hard to catch if you keep this as a manual task, even if you have kind of security focused people on the team. And so this is why we created Checkov. Checkov is open source. It was released in December 2019. So just before we all had a wonderful year at home to spend time learning new things. And Checkov is designed to statically analyze for known best practices in lots of infrastructure as code formats. For example, Kubernetes manifest, for example, Terraform, for example, AWS CloudFormation, serverless framework. The idea being that Checkov will allow you to kind of scan those manifests and find common security misconfigurations before that security issue becomes real. An issue in a Kubernetes manifest or in a Terraform manifest isn't a problem until it's actually deployed on a Kubernetes cluster or creates some, for example, AWS objects. Those are the things that are then vulnerable to attackers. The actual manifests themselves, it's a great place to do that first sweep, just like you'd lint, just like you'd test your code, just like you'd run integration tests and unit tests, etc. The idea behind Checkov is it's not only the scanner, the policies that the scanner comes with out of the box, which the whole point is it's a single tool, it's immediately usable and useful across all of those different all those different infrastructure as code styles, Kubernetes, Terraform. I'm going to stop repeating them and just focus on Kubernetes at this point. But the whole point is those checks are built into the Checkov code base. Therefore, kind of your policies are version controlled, peer reviewed. We accept pull requests. We have a vibrant community of over kind of 50 continuous contributors across a range of companies and different industry sectors that are all kind of contributing their own checks. And also, if those checks are private to you, you can still source control them because Checkov allows you to pull in a specific Git repo of custom checks to run at the same time. So if you do need private checks that you don't want to expose to the world, that's supported as well. And it's written in Python. And a lot of people kind of ask us, especially in the CNCF community, where Go is definitely the language du jour, like why Python? And it's the right tool for the job. We find a lot of security engineers that have spent, a considerable amount of time automating security operation centers, automating kind of reactive scanning of existing environments, kind of before the whole kind of DevSecOps movement, when maybe there were two separate teams. A lot of security engineers are already very familiar with Python. They're very happy to kind of read through, for example, this is the Kubernetes CPU limits check. And as you can see, we're using inheritance. We're inheriting a base case check. There's a load of inherited definitions, which are really, really simple to go, okay, well, if I have a resources section which has limits, which has CPU, I have some CPU definitions limits. If I don't, let's fail the check because we want to check that the manifest has CPU limits. It's very easy to read. It's very easy to understand. It's very easy to add your own checks. And we find whether you're kind of engineering team or kind of security team, Python is a really kind of low barrier to entry language for both teams to collaborate on policies, rather than, for example, having to learn a new domain specific language to write policies and then write adapters for your infrastructure. So that hopefully will answer the why Python why Python question. But yeah, we do get a lot of industry contributions because of it, we think. So very, very quickly, let's kind of see what that looks like on a developer's machine at this point. So at this point, I'm going to give a shout out to a project called Kubernetes Goat. You can find it here on GitHub. And Kubernetes Goat is purposely vulnerable Kubernetes infrastructure for learning and training purposes. So if we're looking for some Kubernetes manifests that are definitely going to have horrifically bad security defaults, Kubernetes Goat is a good place to go. And we can install Chekhov a number of ways. It's in pips. You can do, pardon me, pip install Chekhov. We also have it on brew, so brew install Chekhov, or just go to Chekhov.io for all the docs and information. So I already have Chekhov installed, version 10629. And what we can basically do is tell Chekhov to scan this directory recursively. And as you can see, it's going to go through, it's going to find a load of Kubernetes YAML, which we all love. And it's going to highlight that there are a lot of security misconfigurations based on the built-in Kubernetes checks in Chekhov. So we can see here, you know, secrets as files are better than secrets in environment variables. Readiness probe should be configured. Read-only file systems for containers where possible. All suggestions from the Kubernetes CAS guidelines. If you want to see what the version of Chekhov has in terms of built-in checks, you can do Chekhov list as well, which will show you all of those. And if we grep that for a case, we can see all the Kubernetes specific checks that we're checking against when running Chekhov. Mini demo done. So that's kind of the, the easiest kind of intro to Chekhov way of using Chekhov, kind of almost pre-commit. You can also configure this easily to run as a pre-commit hook. Like all CI/CD style tools, Chekhov will exit with a return code of 1 if there are any violations. You can also specify a flag to just say, just show me the violations, don't show me all the past checks as well. So this is a fine example of a developer just using Chekhov on their local machine before they push to GitHub, before they do anything like that. But obviously that's not ideal. That's still manual work. It's less manual than kind of going through all those manifests yourself once you get that Jira ticket, but we can do better. So instead of kind of pre-commit, let's look at some more automation. So for exactly that reason, we have a Chekhov GitHub action. This is prepackaged. You are able to specify directories or just recursively normal. You can display only failed checks. Like I was saying, you can scan for only a specific framework. If you know this repo, for example, will only contain Kubernetes manifests, and you can even skip certain noisy checks if necessary. And with that, we can see, for example, that on a given repo, so for example, here on TerraGoat, which is a Terraform purposely vulnerable set of manifests, just like Kubernetes Goat is for Kubernetes. This one's written by us here at Bridge Crew. And you can see we have a GitHub action set up to just run that Chekhov action. And whenever we receive a pull request on that Chekhov, on this repo, we will get some lovely output and block that build and highlight to that pull request that checks have failed, just like you would with any other code base, so that you can make decisions on not allowing more vulnerable infrastructure as code or more vulnerable Kubernetes definitions into your infrastructure as code repo. So that, in a nutshell, is the way we would use Chekhov ideally. So instead of kind of doing it pre-commit, and there's nothing wrong with doing it pre-commit, but it is better doing it as, CI/CD, especially with all these wonderful Git repo hosted companies now giving us free compute. We might as well run Chekhov against pull request and against commits to your main branches to block the build, just like you would with any other style of test or security test. And again, this helps us prevent issues ever getting to production, ever becoming a vulnerable object. And then the second thing I wanted to talk about isn't just your own Kubernetes, your own manifest, your own pod definitions, your own containers. Moving fast that we talked about earlier always generally contains using other people's dependencies, standing on the shoulders of giants, using the work that came before you, copying and pasting from Stack Overflow, which is one of my favorite Fake O'Reilly books. We all know that at some point we are going to be using third-party Python modules, third-party Go modules, third-party NPM modules. Just like with code, we're probably going to use existing modules for Kubernetes, be it Helm, be it Kustomize, etc., etc. So going back to kind of the idea of looking for infrastructure checks like this graph before, when we were kind of trying to work out what checkoff needed to be based on data, based on what issues we were seeing with people's configuration in the wild versus kind of security guidelines. We have the same thing for Kubernetes. So what was the Helm hub is now the kind of open source CNCF artifact hub. And, here there are a great number of Helm charts, which realistically, if we compare like a Terraform module, what is the kind of Terraform module equivalent for Kubernetes, like sharing Kubernetes manifests to achieve a specific goal? It would be a Helm chart. So rather than look at individual Kubernetes manifests we find online or customers Kubernetes to work out what the commonly bad security configuration is, we took a sample snapshot of data from the artifact hub and started to model that against checkoff checks by individual Helm chart, by repo, by product, by tool, etc. So what we've ended up with is we took a very small sample. We're going to carry on working on this data and produce some insights from it, and see if we can work out a way to kind of tie this back into checkoff, because also if you're familiar with Helm, you'll know that Helm actually regularly, a Helm chart depends on other Helm charts. So, it'd be good to know right back up the stack of Helm charts what the security posture looks like of the thing you are about to deploy, just like you want checkoff to scan your own handwritten Kubernetes manifest itself. And so we took these Helm charts to see if this was also something that needed investigating. And as we can see, there are a number that don't match the security requirements based on the CIS Kubernetes guidelines. Now, some of these don't really matter. For example, templating out namespaces, which are default because we're just rendering them locally. There are some things in here that aren't specifically an issue. But then we also do see quite a lot by default that are privileged or are running on latest or a blank tag rather than a specific version, which means your manifests aren't kind of repeatable as you might expect them to be, or secrets are in environment variables, or containers are sharing the host network namespace, which we've already covered, and obviously people will take examples like we do with code, like we do with Stack Overflow, like we do with Terraform modules. People will take base Helm examples that are very clearly marked as kind of, not production ready testing only. And these things will end up accidentally getting to production, especially if it's a dependency of a dependency, because it's that security versus usability. So just being aware of these things automatically in your CI/CD pipeline before your Kubernetes objects actually become real by scanning in the manifest stages, is just an extra positive step that you can automate just to give you that visibility of what you might be exposing yourself to. And there, just for the slide deck, is a list just focusing on the top failed rather than a mixture of failed and passed. So based on that, as I said, we're working on some improvements to Chekhov that you'll see over the coming weeks to actually make this kind of easy within Chekhov. But right now, again, using CI/CD, it's pretty easy to get this kind of Helm security posture, just like we saw with the previous example with your own Kubernetes manifests. So this link here goes to a blog post where I kind of wrote up a slightly custom version of the Chekhov GitHub action workflow, which specifically kind of goes and finds Helm 3 manifests, goes and templates those out, and then also runs Chekhov against those, so that if you do have charts as part of your infrastructure as code, as well as just your own hand-rolled Kubernetes, you will be able to kind of check your security posture across those as well. Now, by default, I set this to quiet, but obviously you can see from the output here, this passed, but you could easily set this to, like a normal Chekhov run, exit with a 1, so that you don't have to so that you don't have to progress into your kind of deploy pipeline, or you can have a manual step to kind of go and investigate whether the security posture that's been found in those modules is, acceptable in terms of risk for, whatever the project or whatever the environment, whatever your current security response in your kind of automation and pipeline is. Chekhov, with this kind of simple little Helm CI/CD action, will make a nice contribution to that. And so with that, they are the kind of main things that when we're looking at infrastructure as code security with Kubernetes, certainly from a pre-runtime, when you're still in the manifest stages, they're the kind of things we are caring about. So we're caring about not only your infrastructure, but your Kubernetes. I'm just going to take a moment to look at the infrastructure itself. And to do that, I'm going to go back to, as I said, Kubernetes Goat is one vulnerable set of Kubernetes manifests, but we also have TerraGoat. And if you're running infrastructure as code, they might be in different repos, because one might be your kind of base configuration for multiple teams from, a service team that is providing the Kubernetes namespaces or providing the infrastructure. But just to highlight, as everything is kind of related here, and Kubernetes clusters don't just appear, even if you're using a managed Kubernetes service from pick your favorite cloud provider. If we go into TerraGoat, which you can get from bridgecrew.io on GitHub. If we go into here, we can see that we have multiple Terraform modules for different cloud providers. And if we go into AWS, for example, we have multiple Terraform files, including somewhere, for example, a Kubernetes cluster. So if we go and look at this, what we'll see is kind of IAM roles, a VPC, kind of all your regular building blocks of AWS, and then a definition for your EKS cluster itself. And then what we can do is, again, we can run Chekhov here. Instead of on a directory, we can just run it on a specific file. And we can find things that, again, affect your Kubernetes security posture. It might not be your developers deploying pods, but it's still with the same tool, because we can scan multiple infrastructure as code styles. It's still something you should be mindful of. And if you are provisioning clusters, you should be taking into account. So for example, we should have control plane logging enabled, so we can go back and see what's going on. We should make sure the Amazon EKS Kubernetes endpoint is not open to the world. We should make sure secrets are encrypted at rest in our environment. We should make sure the public endpoint is disabled. And then, we have some pass checks as well around IAM policies not being too widely open and not being allowed to be assumed by principals we don't expect. And, all that regular Amazon access control stuff. So again, just kind of, the infrastructure is one, the Kubernetes deployments are another. You may be abstracted a further step through Helm and its dependencies, but using a bit of CI/CD magic, we can kind of get a good view of all of those issues and the remediations necessary pre-deployment with Chekhov. Now, the last thing I want to show is these guides. So for every output, you will get a guide link. And this, in most cases, is just a bit of context. So if you have this in your CI/CD, and you have developers, again, that are focused on getting their job done, focused on kind of reaching their next, next week's deployment release, not specifically security mindset, and they see these CI/CD issues blocking a deployment, this gives a nice bit of context for each issue. This gives kind of the why and what and the rationale behind having this as a check in the first place, which should allow engineers to kind of self-serve and to kind of understand the security requirements that the check is flagging. It's also quite nice to know that the way the Chekhov action is written, we now integrate with some new features in GitHub that give us these kind of lovely annotations to kind of really easily see the outputs rather than having to scroll through the CI/CD output. And that really brings us to the end of build time. But that's not the end of the story, because once you have your, tested, certified Kubernetes manifest, be it Helm, be it handwritten, you're still going to deploy those. And yes, the pods themselves, the containers themselves may not be long-lived. Kubernetes might be handling the lifecycle management of those. But that actual deployment manifest is going to be on your cluster potentially for a long time. And not only that, there might be things that haven't been deployed via infrastructure as code. There might be, whether it's in your cloud provider or whether it's actual Kubernetes objects, there might be things that have been deployed before you had your latest round of kind of automation, or, before this team was really set up to kind of automate its deployments. The greenfield infrastructure as code, we appreciate, is a luxury that not every team has, especially if you inherit other projects. So the final piece of the puzzle is runtime analysis of a Kubernetes cluster. Now, historically, and with most configuration types, this is not something Chekhov is trying to tackle. You would go for a different tool like the Bridgecrew platform, or open source tools like Prowler, to kind of go and look at your runtime configuration and kind of go, hey, this isn't now just a manifest describing an insecure Kubernetes deployment or an insecure Amazon S3 bucket. This is an actual insecure Amazon S3 bucket. You have public write access. This is probably a bad idea. So historically, this is, or not historically, my apologies. With most styles of configuration, this is not something Chekhov cares about. Chekhov cares about scanning your manifests. However, with Kubernetes, you can very easily request the initial deployment manifest or the same format of a running object in the format that a deployment manifest is in. Whereas with kind of cloud provider objects and with things like a Terraform plan file, if you're familiar, that's not the case. The deployment state definitions are very different to the running state definitions. But with Kubernetes, they're one and the same, which actually allows us to really easily create a Kubernetes job, which effectively is just Chekhov. And you can find this again in the Kubernetes branch of Chekhov, Bridgecrew.io. The Kubernetes directory of Chekhov in Bridgecrew.io/Chekhov. And within there, you will find a deployment manifest to effectively install a Chekhov job onto your cluster. And that does exactly what you would think it does. It basically asks the Kubernetes cluster for a JSON definition of all your currently deployed pods, services, et cetera, all the objects you can think of, and runs those against the Chekhov checks. And so using this, you can not only prevent via pull requests or prevent via scanning on any commit, basically using CI/CD with Chekhov, making sure that not only your underlying infrastructure as code, but also your Kubernetes deployments are not, obviously vulnerable to any of these kind of checks. You can do that pre-deploy, but then you can also use the same set of checks to validate that those, secure defaults in your infrastructure as code are actually staying secure within your Kubernetes cluster. And, no one's come along and manually done a kubectl edit and changed something to get it working. Chekhov will then be able to flag up, actually, you have an issue in production. Now, maybe that wasn't insecure, like I've just said, when you did deploy time, but through that you get, simple drift detection. You go, hang on a minute, this wasn't what I deployed, because it wasn't showing a violation at deployment, but it is showing a violation in runtime. So using the same policy definitions across different points of your pipeline actually gives you this wonderful scenario of kind of continuous analysis. So pre-commit, whether you're just running Chekhov locally or as a pre-commit hook, continuous integration, and then also comparing those violations against the output from your running Kubernetes cluster. And this is really what we're trying to get to with Bridgecrew, with our open source tools. We want infrastructure whether it's, your low level kind of AWS infrastructure or higher level abstractions such as Kubernetes. We want infrastructure to be developed and secured in the same place, and we want that to be part of the regular DevOps pipeline. We saw with ops getting integrated with dev that it makes a lot more sense. Not throwing things over the wall makes a lot more sense. Bridge Crew's trying to do the same through these tools with security. Your security posture, things you are willing to make exceptions of, should all be source controlled, should all be in your CI/CD, and your developers should be aware of it rather than security being bolted onto the side. We are trying to get to the point, as you've seen, with blocking in CI/CD, where issues are automatically prevented from being deployed. And all of this should allow kind of security resources you may have within your team or within your organization to go and work on kind of, bigger ticket items, looking at, data trends, looking at future threats, looking at those things that aren't just day-to-day firefighting, because firefighting should become a non-op because it's just built into your DevSecOps pipeline. So before we get to any Q&A, of which we have plenty of time for, I'm happy to add, the takeaways here are really, keep your manifest secure and do that with kind of open source automated scanning. Know your imports, know your dependencies, know what you're pulling in, Helm, Terraform, third-party modules, just like you would need to be careful of that with any other code base. Infrastructure as code, treat it like a code base, know your imports, and again, use automated scanning like we just demonstrated with Helm to do that. Have a fast feedback loop on configuration changes. So do kind of block and annotate pull requests, do highlight that information to developers. With the pull request checkoff action, you can very, very easily just scan the changes in that pull request. So you're not going to get a million violations from an existing vulnerable repo. And maybe you just start by making sure you're not introducing new issues by taking violations highlighted in pull requests really seriously across both Kubernetes and your base infrastructure, which allows the technical debt of then fixing issues in your existing, main repo, in your existing code base a lot easier, because it's not going to get that number of issues isn't ever going to get higher because you've turned off the tap, which allows you to kind of slowly prioritize and tackle existing issues. Build time and runtime. As I said, we don't have open source tools for runtime, but it is important to do both. And as you saw with Chekhov, actually, we do have a tool for runtime for Kubernetes, because it allows us to speak the same language, both build time and runtime, which is kind of a benefit in Kubernetes, which we don't have in Terraform, things like that. And obviously version control your policies, and kind of this is done for you with the built-in policies of Chekhov, because they come with a specific release of Chekhov because they're built into the code base. If you go to Chekhov.io and get into contributing in the docs, you'll see another video of mine and a step-by-step instruction for kind of writing your first Chekhov check. It's super simple. Give it a look. I've got my VS Code environment set up on there, documented as well. So if that interests you, please take a look at that or give me a reach out on Twitter. So yeah, version control your policies, super easy to do if you're using just the Chekhov built-in policies because they're already there. If you're not using the Chekhov built-in policies, we support loading in policies dynamically when you run Chekhov from another Git repo. So again, you can keep your policies versioned in a way that suits you. And that is the end of my happy little Kubernetes, Helm, Chekhov, and all things infrastructure as security scanning webinar. Really looking forward to any questions you have. If, as I said, you want to have a conversation about writing checks, if you want to get more involved in codified security, we are available. I'm available there on Twitter. There's my email address. And slack.bridgecrew.io, we have a codified security Slack channel, which is kind of, the developers of Chekhov, contributors, and just kind of all general codified security chats and topics. So please do reach out to me with any kind of further questions after this event. Thanks very much, everyone.
All right. Thanks so much, Matt. That was a great presentation. So far, we don't have any questions submitted through the Q&A box. Just a reminder that if you have a question for Matt, there is a Q&A box at the bottom of your screen. Feel free to submit a question through there or via the chat. We'll just give folks a few seconds here to see if any questions come through. Um, oh, perfect. We've got one right now. Oh,
No worries. I'm gonna use this opportunity to have a quick sip of coffee. So all good.
no worries. I know you kind of were on a roll there. Somebody's asking about your Twitter handle, Matt, and it's right there on the screen. It's Metahertz. Sahil, I'm sorry if I'm saying your name wrong, but Matt's Twitter is right on the screen there for you.
Nope, that is all good. It was a badly thought up joke on the fact that it's abstractions all the way down. So, but yes, very annoying when you try and give someone your email address.
No worries. All right. Well, going once, going twice. Okay, no questions. But again, feel free to connect with Matt via Slack. His Twitter is here and also his email address. I'd like to thank everyone for joining us today for today's CNCF webinar. A reminder that the recording and the slides will be posted later today to our CNCF webinars page. Hopefully everybody stays safe out there. Continue to, wear a mask and we'll see everyone real soon. Thanks again.
Thanks, everyone.